Have you ever just looked around? I mean, really looked at everything you can see and touch and just wondered, what is all this stuff actually made of? Well, today, we're going to go on an incredible journey to find out. We're going to shrink ourselves down way past what our eyes can see to find the fundamental building blocks of the entire universe. I mean, that's the big question, right? Think about your phone, the air you're breathing, the chair you're sitting on. They all seem completely different from each other. But what if they aren't? What if, deep, deep down, they're all connected? Let's start peeling back the layers and see what we can find. So, scientists have a really simple word for all of this: stuff. They call it matter. And matter is just anything that has mass and takes up space. Super simple. That means solid things like iron, liquids like water, and yeah, even invisible gases like air. It's all matter. It's the physical substance of our universe. So, first up, the world we see. And to get started on our little journey, we don't need some fancy, high-tech laboratory. Nope. Our very first clue is hiding in plain sight, in something you could probably find in your kitchen right now. That's right, just a glass of salt water. I know it seems almost too simple, but believe me, it holds the first clue in our investigation. Because on the surface, it just looks like plain old water, but we know there's something else hiding in there, don't we? What we've got here is what's called a mixture. You can think of it like the salt and the water are just hanging out together in the glass. They're physically combined, for sure, but they haven't chemically changed into some new substance. You could even get all your salt back just by boiling the water away.
Okay, next up, elements, compounds, and mixtures. So, we know we can separate a mixture, but what are the individual things we're left with? That's our next step.
So let's imagine we've evaporated all the water, leaving behind those pure salt crystals. Now we have two totally distinct substances. And these two, the water and the salt, are perfect examples of two of the most fundamental categories in all of chemistry: elements and compounds. And this really shows you the core difference. Over on the left, we have an element, like iron. An element is a pure substance. If you could break down a piece of iron into smaller and smaller bits, all you'd ever get is more iron. But then, on the right, you see a compound, like salt. Salt, or sodium chloride, is actually made of two different elements, sodium and chlorine, that are chemically bonded together to create something entirely new. All right, part 3, atoms and molecules. We've separated our mixture into compounds and elements, but now we're going to zoom in even further. It is time to meet the true building blocks of matter. Okay, so this is where it all starts to click together. The smallest possible piece of an element, like our iron, is called an atom, and the smallest piece of a compound, like water, is called a molecule. So, put simply, atoms are the building blocks for elements, and molecules are the building blocks for compounds. You can honestly think of it just like a recipe. To make one single water molecule, you need a very specific set of ingredients. You take 2 atoms of the element hydrogen, you add 1 atom of the element oxygen, and you bond them together chemically. And there you have it, 1 molecule of water. And that famous chemical formula, H2O, is just a shorthand for that recipe. H is for hydrogen, that little subscript 2 tells us we need 2 of them, and O is for oxygen. And to make things easy, every single element has its own 1 or 2 letter symbol. H for hydrogen, O for oxygen. Now you might be looking at iron and wondering why Fe. Well, that's because some symbols come from older names, in this case the Latin word ferrum. It's kind of like the universal language of chemistry. So, part 4, the indivisible particle. It seemed like everything just came down to atoms. And for centuries, this was pretty much the end of the story. Scientists were convinced the atom was the final, indivisible piece of reality. And this idea is ancient. Around 400 BC, the Greek philosopher Democritus came up with the name atomos, which literally means uncuttable. But it wasn't until 1803 that John Dalton came along and turned this philosophical idea into an actual scientific theory based on real experiments. Dalton's theory was revolutionary. It basically said that atoms are fundamental. They can't be created or destroyed, only rearranged. The best way to think of it is, like, they're the ultimate Lego bricks of the universe. You can build anything with them, but you can't break the bricks themselves. All right, our final section, inside the atom. But, as science advanced, some cracks started to appear in Dalton's theory. People started to wonder, was the indivisible atom really the end of the line? For over 2,000 years, the answer was yes.
but modern science was about to give us a plot twist that would change everything we thought we knew about matter.
The answer, as it turns out, was a huge, definitive no. The atom is not indivisible. It's actually a container for even smaller particles, protons, neutrons, and electrons. Now, Dalton's theory was a giant leap forward, but the journey into matter had one more incredible layer to reveal. So here's how it works. At the very center is a dense core, the nucleus, and it's packed with positive protons and neutral neutrons. Then, zipping around that nucleus are these tiny negative electrons. But here's the crucial part. The number of protons is everything. 1 proton, and you have hydrogen. 6 protons, you've got the carbon that makes up a diamond. 8 protons, and it's the oxygen you're breathing right now. The identity of every single thing is decided by that one number.
What a trip, huh? We started with a simple glass of salt water, a mixture we see every day. And we zoomed in, past the molecules, past the atoms themselves, all the way down to just 3 fundamental little particles: protons, neutrons, and electrons.
Which leaves us with a final, kind of mind-bending question. If the entire universe, from stars to salt water to you and me, is built from just 3 tiny particles arranged in different ways, how does a recipe that simple create all the infinite complexity and beauty we see all around us? That's a question worth thinking about. Thanks for joining me for this explainer.